Right, so let's see. So here's the plan. I'm going to continue working on the LOLCODE Babel macro compiler thingy, and we're just gonna see how far we get. I honestly don't know right now. Last I remember working on it was last week, and I was having trouble making, what was it called? Wrong thing. I was having trouble with the having trouble with if statements. So we're now gonna try to ignore if statements and try to implement some of the other stuff, and then once we get the other stuff working, we're gonna get back to if statements. So I'm gonna run my tests to see exactly where we're at and what breaks, and then we're gonna move on to other tests that are not implemented yet. And I think I need to make my music a little louder because I can't hear shit. Cool. Alright, so we got LOLCODE, and we have a bunch of stuff that fails. Think git log, where were we? Getting stuck on conditionals. Cool, so we have function definition, assignment, declaration, functions work. Give me if this one doesn't work, indexer. Oh, I know what the problem was. We have a problem with built-ins. So we gotta make built-ins work first. Let's see about built-ins. We were using, what was it called? So if I go to GitHub, I'm going to be able to see the lol.js implementation that we're using. lol.js, that's me, Swiss lol.js, go to source, lol.js, zoom this in so that we can see it better. And here we have a bunch of built-ins, right? Yeah, built-ins, both same and stuff like that. Let's see, where are the built-ins? Cool. So how do we implement built-ins? That's the real question here. So let's I think we're gonna have to make a new test case for built-ins and implement those separately. Error false, I have no idea what that means. Code, and we say import lolcode from /macro, const code equals lolcode \backtick, and we start with hi and k thanks bye. Cool, and let's okay, why is it doing that? There we go. Now, the hell? Why is my prettier acting all funny? Okay, Command Z, Command Z, Command Z, Command Z, Command Z. Backtick this guy, or escape this thing. Okay, thanks. Bye. Now it should save normally. Okay, so we're going to say I has what is it? So assignment, I has a var. Okay, we're going to say I has a var is 10, right? So that should give us a thing. Let's see. So we say yarn test -t, we're testing built-ins, and let's do -u and see what we output. This should create a variable called var, and it's not its, it's 10. So we're gonna have a variable that's initialized to the number 10, right? Let var equals null. Okay, so it doesn't work yet. Unexpected keyword var. Aha, okay. Thing, let's call it a thing so that it's not confusing JavaScript. Okay, let thing equals null. Oh, interesting. So we have a bug in our function in our declaration implementation. Okay, let's fix that real quick. Declaration. Let's see, console log of the node, and we will see if it has a value as well. Then we can change this null. Name thing value, yep. So our value should be node.value or null. Okay, so what does it look like if there is no value in the its? So we're gonna have to add a declaration test here, but yeah, let's run the declaration again and see what that outputs. So, hey fuzzy buddy, how are you today? So our node console log. Why isn't it printing the node? Oh, it's not printing the node because I removed the thing. Console log node. Let's see. Yarn test t declaration, and we get back that the value is null. Cool. So we're going to say value, and then const value equals, const value is first just declared let value, so let value equals null. Perfect. So we let value as null, and then if no.value is not null, then we say that value becomes this.compile of no.value. So then we are able to define we're able to declare new variables with a value. So the declaration should still look the same. It does, okay. But if we declaration, let's do this. Declaration with value, we're gonna say I has a var, it's 10, and that should declaration with value. This should now render or whatever. It should create a declaration with a value like this. Function let var equal 10. Cool. So that works. We fixed the bug. Yay. Git status git commit -a yarn test -u. Run all the tests to make sure that we didn't break anything else other than the things we already know are broken. Git commit -a -m. Fix variable declaration with value. Cool. And now we can go back to working on our built-ins. Built-ins -u. I has a thing, it's 10, so we now have, is it not outputting anymore? Yeah, okay, it is. So function let thing equals 10. Now, the next one, let's see, not 10. Okay, I know how to do that. How do we declare assign a value to thing? Assignment var r. Okay, so thing r not 10. This should basically set the thing to the exclamation point of like that, not 10. But then not 10 is not really, not 10 is not what would you call it? It's not JavaScript. So we gotta see how built-ins work. How is the original thing that we're mimicking, doing built-ins. So if we go to built-ins, where are they being called? Branch is a normal case statement and has an expression for var name in if log built-ins has own property name. Push program state clone built-ins, otherwise they're a reference to a static property, i.e. a program could override them and break them for all subsequent. I think keeping a reference to the function is fine though. There shouldn't be any potential to escape the interpreter to. So Fuzzy Buddy asks what I'm working on right now. I'm working on my LOLCODE-to-JavaScript compiler, and right now I'm figuring out how to get built-ins to work because I have no idea. So that should be fun. Oh, I know how we can make built-ins work. We're gonna, yes. Let me see if all of the built-ins get translated to function calls. So let's see. Let's see what is both same. Okay, thing are both same, and we say a b. I has a, it's true. I has b, it's false. And let's see what that renders to. So basically built-ins are the standard library. Expecting identifier got a avar bvar bval. Let's do aval bval. Run the tests and we should get function calls. No? I don't know how both same work. Okay, so we go to lol.js JSON and let's see what both same does. Both return p-bin op. P-bin op, so it's binary operation. Simple expression, separator, simple expression. So is it done like that? So basically part of the problem, like I was already explaining last week, is that I also don't know how LOLCODE itself works. So I'm kind of learning both LOLCODE and how to compile LOLCODE at the same time. It probably isn't a good idea. Okay. Let's see. LOLCODE examples. LOLCODE some more examples, tutorials points. Let's do operators. Both same. So the separator is n. So now we should get the thing. No, still an error. Oh, because aval bval. So we say thing becomes both same aval and val, which should be, yeah. Okay, so both same is a function call. But that is not a function call that's going to work, is it? So what we can do, we can then have a parser work on top of that that's going to implement the standard lib. Let's see. So how would that work? We are compiling it. Let's look at the assignment and let's console log the node. Console log node. Because I'm not sure where or how this works. So name becomes both same. Name function call. Okay, so that's a function call. If we go to function call here, console log node. Ah, okay, so built-ins get compiled to function calls. Yeah, which means if it's a standard function, we are going to have to change that. Yes. Okay. So how do we, for all of this stuff, we can implement standard lib like this. So I'm going to copy it, lolcode built-in functions, like this, class JSCFI, close that thing, we go up here. Okay, so we have lol.builtins, or let's do it this way. Import, is it import that we're using? No, it's requires. So we say const standard lib equals require dot slash lol lib. Okay, new, and we say module.exports equals this stuff, and it's lol standard lib.js. Change to React mode like that. Cool. And then when we have standard lib, we are going to here the function call. How can we make this? I guess we can just include the standard lib. That would make sense, right? Yeah, that makes sense. So if standard lib node.name exists, then we are returning something a little different, which is going to be return of standard lib node.name, and the rest looks the same. So we get node.args, and we compile those like that. So we're calling standard lib based on the node name. Yes. Okay, so if standard lib node name exists, then we call that functions, particularly this compile node args, and when we are returning, when we are compiling everything, so JSify here, let's see, macro.js, here this guy is going to assume that when we compile our code, on top of that we're going to add the standard lib. Yes, that should work. So let's see, if we compile standard lib, or should we require it to be imported? Let's see. So macro test, it imports lolcode from macro, so we should be calling lolcode.standard-lib. Okay. So we are importing standard lib here. We're going to say lolcode.standard-lib blah, and then when we are exporting our macro here, module.exports is create macro. What does that actually create? Function my macro references.lolcode for each blah. Okay, so let's see first. Did this use the standard lib correctly? Yes. So we get thing becomes lolcode standard lib not of 10, standard lib both same aval bval. But how do we import the actual lolcode itself? That's the question. Let's see. What happens when we console log module.export? I'm assuming I can just add to it afterwards. So it's function macro wrapper. Is Babel macro true? So I'm not sure right now how to actually test this for reals, because we have this macro.testjs thingy, which is importing lolcode from macro. But how do we add a property to that? That's my question. I know what we can do. We can do this. Yes. So JSify lol standard lib. Where was I? Lol JSify. Instead of lolcode.standard lib, actually let's try it this way. We're going to go into node, and we're going to say const lolcode equals require dot slash source slash macro.js. No, that doesn't work. Yarn build. Let's do build, and then we're going to import it from distribution. So node, and we say const lolcode equals require dot slash distribution. What's in distribution? ls-dist lolcode babel macro.js, like that. Cannot find module dot slash jsify. So this micro bundler doesn't actually work at all, which is quite annoying. ls-dist ls source. I can't remember how we solved this in the lol.js, in the actual lol.js thing, which is silly. What else can we do here? Okay, let's see how did I configure the micro bundler in lol.js. So swizzets lol.js, we managed to make it importable there, but how did we do it? We have this lol.js build micro bundle source index.js outputs to dist prepare main and source. Okay, package JSON main. Is there a source? There's no source. Source slash index.js. Right. Micro bundle source index.js blah, and then in our dist has all of the things. What does index.js do? Index.js exports star from lol.js, lol.js imports parser, parser blah from dot slash parser. I think that was the thing that we did. So if I go into index.js, exports blah from macro needs to do it this way as well. So if we say import JSify from ./JSify and import parser from @swizet/lol.js. So I'm now trying to fix my imports so that they will work correctly with, you know, require Babel. No, not require. So I'm trying to fix my imports so that microbundler understands them, because I think that's causing my issue right now. So import parser, blah blah. Okay, and we say export default create macro, my macro, and then in JSify we have import standard lib from ./lol standard lib, because I think this should work in theory. And here we say, instead of module.export, we say export default JSify, and then in lol standard lib we say just export default all of this stuff. And now if I first run the tests, yeah, running tests should work in theory, I think, I hope. Not from, but from macro.js import from. Please work. Unexpected token. Okay, let's try just microbundle. Yarn build. Maybe that's gonna work at least. Setting options module is deprecated. Okay, so that was cool. Node import lolcode from ./dist/lolcode babel macro.js. Why is importing not working? Node minus version. Node import okay. Okay, so imports and exports don't actually work in Node.js, something I always keep forgetting. But then microbundle doesn't work either, which is quite frustrating. Okay. Okay, so we got that fixed. This goes back to module exports. Index.js is fine for some reason. Oh, that should remain the same. Okay, so I still don't know how to add something to the thing. Microbundle. Let's see if microbundle documentation are able to tell us something. One dependency to build your library using blah produces tiny optimized code for all inputs, npm i-d, then add the scripts tag. Okay. I can't remember how we fixed this problem earlier, but I'm hoping that this kind of works. Let's see, lol standard lib macro. Oh, I know what we can do. We can say module dot exports dot lol standard lib equals lol standard lib. So we say const lol standard lib equals require dot slash lol standard lib, like that, and then in JSify we can say lol standard lib. Perfect. So when I say yarn test -t built-in zoo, that should work. There we go. Perfect. Okay, so we've added support for built-ins. Git add source, git commit -m add support for LOLCODE standard lib. Awesome. Git push origin master. So we've got that part, which means we might be able to go back to, what was it? Conditionals. If. Okay. So let's try that. Yarn test -t if. Will that work? It did. Wait, seriously, that worked? Function true if undefined. Okay, it almost worked. Almost. We're very close. If we go back to JSify and we look for the if condition here, where is it? If equals node compile name condition. Right. So let's console log the node. Console log node. So what does the if node look like? Did we manage to get name is if, body, condition is null. So the condition wasn't picked up, which means if the condition wasn't picked up here, that means my lol code is wrong. If we go here to conditionals, variables, types, input output statements, and flow control. So conditional statements. Oh really? So the general form is any expression. All of the above statements can be written in the same line separated by commas like blah. Example, any expression. Oh really? Yeah, really. Both same names and name. Oh really? Okay. Okay, let's go back to our lol. Let's see how this guy implements it. So eval if no, come on, I know there's an if in here. Wow. Where are they? Eval body, call function, evaluate break, evaluate. So we are evaluating if is evaluate if. Is Mr. Bird already asleep? Yes, Mr. Bird is in fact already asleep. So the condition is node.condition, else ifs, e condition, wait for blah. So if there is a condition, but I don't know how to write a condition. What if we say, oh really win? Will that make a condition? Let's see, because apparently lolcode has an implicit it variable. Okay, how does JSON work? Oh really? Oh, I see. Oh really returns oh really. What does oh really looks like? Oh really, end of line, yeah really, end of line body. So oh really, yeah really, body. Conditional inner maybe, simple expression. Conditional inner no way. What? Maybe both same. Got it. So if there's no condition in the if itself, then we have to implicitly compare it with the previous value. So we can do that like this. We're gonna have to say that condition, so node.condition, so if const c equals name.condition, let's see, and then if c, then we say c becomes this.compile of node.condition. Hey Carlos, how are you doing today? So node.condition, where are we? Node.condition, if condition, then condition becomes blah, otherwise condition is it. So mebes have conditions, otherwise use implicit it. Okay, so how do we get the implicit it? So we get the condition. Now how do we ensure that there's always an implicit it? That's the real question. It means that every time we compile, the result of the previous expression should always be, or rather the result of the last expression should always be assigned to the it variable. So we can say both same 1 2 1 and 2, or really like that. Now let's see what this compiles to. So lol standard lib, both same 1 and 2. If it, then console log true, else console log false. How do we assign this to the it variable? Let's see. JavaScript value of last expression. Last valued expression in JavaScript. There is no standard reified concept of the result of the last valued expression. Blah. Okay, so we don't have that. How can we get it anyway? We might have to slightly modify how lolcode works and say that it needs to be like it are. We might have to say that that would simplify things, but an even better way would be if the conditional, which actually needs that, could do it. Can we get the previous node? Visible, literal, compile. Let's see, what does compile say? Console log of node. Maybe we can see that the node is just an expression. That could be useful. So this is the literal body, that's body for the conditional, literal visible body. So if has a condition and body. Before that we have a literal, which would be the number and the other number, and a argument list, and before that function called both same. Both same is just a function call, name body, with lines, function call, and so on. Okay, so we're not going to be able to do that, unfortunately, and I don't think we can. Yeah, we don't have access to the previous node, which means we have to, we're gonna have to change how what's it called, how LOLCODE works. So we're gonna need, it's gonna be a quirk, otherwise use implicit it, assume so implementation quirk, previous expression must be assigned to it. Yeah. Okay, so then that means that when we create a body, we want each yes, so node lines is blah, and then we're going to say node lines equals node lines dot unshift, let it equals null. So we're going to always start with a null it, and let's see if that works. So every body should always have its own it, I think. Yeah, that's close enough. It's not, oh, not unshit, but unshift. Let's see if that works. Yeah, perfect. Okay, so now in our macro test, here we're going to say it are both same 1 and 2, and we're now going to have working JavaScript code. See? We always have it that is defined but doesn't have a value at first, and then we say it equals lol standard lib both same 1 and 2. If it is true, then we redefine a new it because we're in a new context, console log true, otherwise console log false. Cool. Get status, get commit -a -m, support for conditionals, and semi-implicit it. So this is one of those things, because we're compiling it, because this is not an interpreted language anymore, we have trouble. Now let's see if we can have if-else statements and how those might work. If else, we have LOLCODE, hi, it are both same. Oh, really? Yeah, really? names and name, maybe both same, it and false. Then we say visible, visible maybe. Let's see what that compiles to. And it could potentially just magically work, but I think it won't. It did not. I think it didn't. Let's try that again. Maybe both same. So no, we got if and else. So we go back to our conditional, or rather, let's see, what does maybe compile to? Maybe conditional inner maybe blah, maybe no conditional meh. Okay, let's see what what kind of node we get. If console log of node, and let's see if it has if else conditions. Else ifs, or else if, not if else. Else if So we're getting very close with this LOLCODE implementation, let's be honest. Let's see, so we now have else ifs, which are all examples of blah, of more conditions, which means here when we're rendering it, we're going to loop through I see. Okay, so first we're gonna say if node.else body. If that's defined, then we have let code equals blah. Okay, if node.else body. So if we have an else, then we say code plus equals an else of this stuff. If node.else ifs, and then we return the code. So to support else ifs, we go through all of the else ifs and just put them into the render stuff. If node else ifs, we just put them afterwards, which looks like this. Code plus equals node.else ifs, else ifs.map. Node becomes, what are we returning? We are returning else this.compile of the node itself, and we're joining that with new lines. Let's see what that gives us. And it worked. Voila. So we have translated all of this. So we say it are both same. Oh really? That's the if, then blah, else if blah blah blah. Perfect. So that worked really well. At least I think it did. Yeah. Let's see what happens if we run all of the tests now. We're getting very close. Cool. So if we now look at our snapshots, we'll see that most of it is implemented already. Git status, git commit -a-m. Support for else if conditionals. Git push origin master. So we have now reached the point where our LOLCODE implementation is Turing complete. We have recursion with functions, and we have so we have recursion and we have conditionals, which means our LOLCODE implementation is Turing complete, which is a great success. Ba-ba-bam. Cool. Okay. Now what was the next thing I needed? So we have ifs, we have that stuff. Now what is gimme? That looks useful. Or was I going alphabetically from here? Do we have cast? I don't think we have casts. Yeah, we decided to ignore casts. Evaluate cast. I don't think that's necessary anymore. Okay. We have declarations, we have function calls, we have function definition. Let's do gimme. What the hell is a gimme? Input. I think it's an input output. To take some input from the user, the keyword used is gimme. It is a function which can take any number of variables as input. It takes yarn as the input and stores the value in any given variable. Gimme var, by the way, get input string into variable. When this code is run, it will ask you to enter a number and then print the number back in the next line automatically when you run this code, so that doesn't seem very useful. We're going, or at least it doesn't seem useful in a let's implement it as a prompt, I think. JavaScript prompt. Person prompt blah. Okay. Let's see then how gimme works. Gimme here. Gimme, which is just a prompt. Okay. So gimme, we should run this as gimme. How is it written here? Gimme var. I has a var. It's a yarn. By the way, declare. Oh, by the way, is a. Right. So we say I has a val. Gimme val. Type something and enter. Okay. Cool. Gimme val. Yeah, it's not very useful, but you know. Gimme, where is it? Visible, blah. So gimme node console log of node yarn test of gimme, and let's see what that does. Macro test.js. Yeah. Variable val. Okay, perfect. So we are just returning return dollar of no.variable equals prompt, and that's literally what it does, right? Yep. Okay, and let's do it as window.prompt so that we are more safe. Where is it now? Window.prompt. Cool, we got that. git commit -a -m, and we say implement gimme /prompt git push origin master. Now what's the next one? Come on, where are you at? Identifier. What is an identifier? Oh, we already implemented identifiers, we implemented ifs. What is an indexer? That sounds useful. Let's look at our lolcode stuff. Indexer. Indexer. Simple expression. Unfortunately, this introduces a few SR conflicts, but test pass, so I'm okay. Indexer, what do you do? It's possible that indexer is something that's only useful when lolcode is an interpreted language and not when it's a compiled language. Node LHS, what? What is the JSON thing saying? Indexer. What? I have no idea what this is doing. Evaluate indexer. So left hand side, right hand side gets vals, and then index of, I have no idea what that does. Okay, we're gonna skip the indexer because I don't know what it is. And I don't think it's a part of the actual literal. We have literals, don't we? I'm pretty sure we have literals implemented. We do. Loops. Yes. Okay, so loops are the next big thing. Evaluate loop. Cool. So to evaluate a loop, let's see how loops work. And we're then going to write a test for loops. Yarn test -t loop -u. I'm in your oh, cool. No op loop. So we're going to say I'm in your loopy up in your I till both same I and then I'm out your loopy, and we're printing visible sum of, oh yes, I and 1, and we're going to say I has I, it is 0. Cool. And let's see what that compiles to, and it's going to error out. It should error out. Wonderful. Okay, and this should be saying that loop is not implemented yet. No, it's not. It is. It's 10. Okay, it is. It's 0. Cool. Okay, now let's implement a loop. JSC5 visible literal loop equals node console log of node return loop, and when we're done with this one, I'm going to stop live coding and go to bed. So let's see. Loop. Okay. Ooh, we have a lot of things. So it's a loop, and then we have the body, the op, which is a loop operation, and then we have a condition, which is a loop condition. Cool. Which means this is going to be a for loop. So we're going to return for, we skip the first one, and we say this.compile of node.op. No, that's node.condition. So we have this.compile of node.condition, and then we have node.operation like that. So what am I missing? Like that. So this compile node condition, or let's do it this way. Const equals blah, const op equals the operation op, bam, for blah, and then here we have the function body or the loop body. Const body equals this dot compile of node dot body. Because we already know how to compile bodies, all we have to do make sure is that we also know how to compile loop conditions and loop bodies. Yes, I think. Okay, now we should get a new error. Throw new error, not implemented loop condition. How do loop conditions work? Loop condition equals node blah blah blah, return true, because why not? Console log of node condition. Let's see, what does that say? Loop condition has an expression, which means we should really just okay, for now it looks like we should return this dot compile of node dot expression, and that should give us a mostly functioning loop. But I should check what does the check thing do? Loop condition. Loops can have an empty condition, which is the equivalent of while true. It's easier to handle that here than in the loop node. Node check while. Oh, okay, because we can have while or until. Very, very nice. Okay, so if there is no node, right? Yeah, if there is no node, we return true, which means it's always going to loop. Otherwise, we return if node dot check is while. So if we're running the node while this is true, let's see. So if until the condition is true, yeah, okay. Otherwise we return the opposite of the expression. Let's call it just expr, and this is going to be expr, and we say const expr equals this compiled expression. Cool. Now we have the loop condition, which means we need the loop operation. Node op symbol. Initialize the loop symbol to 0 if it is not defined yet. Ooh. Okay. Let's see. Yarn test blah. And we say throw new error loop operation. So loop operation equals node. We return I++, and we console log the node to see exactly what it does. Loop operation command increment symbol I. Let's see. Loop operation. They don't actually. Operation. Op. Loop condition. Let's see. So what do they do with no.op? Evaluate loop condition, evaluate loop. So if no.op, then we create the symbol from the symbol, otherwise we set it as blah. If node.op get symbol, increment symbol +1, otherwise symbol -1. Really? Up, oh, because it's up-in, or the opposite of up-in is, I don't know what the opposite of up-in is. Let's see, up-in, nerfin. Nerfing your identifier is decrease. Okay. So let's see, package.json, macro test, lol_stand.lib. Where are we? Index.js, JSify. Alright. So we're not gonna actually do node.op differently. Where am I? But here, loop. So the op is going to be like this. Op.symbol, and then symbol is going to either, if op dot increment, right? Now command op dot command equals inc, then we ++, otherwise we --, and my camera just ran out of battery, which I should fix. Okay, I should be back. Inc or deck. Cool. Const inc or deck equals blah. Let's see. Am I moving? Cool, I'm moving. So we have inc or decrement and op.symbol. And now okay, so now if the symbol is not defined, we define it. That's a problem. How do we do that? I know how we do that. We're gonna say, so when we're compiling this at compile, how would I implement this? I would say if type of I equals undefined, then I would say type of I is undefined, then I would just define it, then let I equal 0, otherwise I would take I. Okay, so we're going to say op.symbol is undefined, then we take op.symbol Otherwise, we just take ob.symbol, and that should work. Let's see if it does. Throw new error, not implemented loop operation, because we're not compiling that shit anymore. Right? Right. Let's const op equals no dot operation. Op dot command. Oh, it's just no dot op. I'm an idiot. No dot op incordec, and we say const loop symbol equals all of this stuff. Loop symbol, and we say right. Let's see if that works. Yes. So if type of I is undefined, then we define I as 0, otherwise we take I, and then while I and 10 are not both the same, we increment I and we console log I plus 1. Yes. Cool. Git commit -a-m support loops. Git push origin master, and now I'm gonna tweet this out and say that we are done for now. Oh, and let's output everything. -u, and we go to Carbon and we open Twitter. Right, and I now have 5 minutes. Great LOLCODE success. Where is my snap? Loop. Where is loop? Export PNG. Great LOLCODE macro success. Very important computer science work. Okay, and then we take this guy. Oh. No. But where did my loop go? Loop. What? I know there's... Where is my loop code? Fine then. Let's just overwrite everything with the loop. Why are you writing it for the loop condition? What? What is it complaining about? Unexpected token. Okay, so that's what's not working. Okay, let me quickly. Okay, I was mistaken. It does not work yet. So where was I? Okay. So where we this isn't actually. I know what we can do. No, but we would want to I guess we don't have to support really ugly code, do we? So we can say let underscore op.symbol equals type of op symbol equals undefined. We return 0, otherwise we return op symbol, and then here we add an underscore, and now when I parse this it should work. Yeah, it's not the best, but it should be fine. It bothers me that we don't support the case where you might want this to actually be changing. Is that a problem? Most of the time it's not going to be a problem, but it could be a problem for people who are trying to be tricky. Can I fix that? No. Yeah, like what do we want? I know what we want. So then afterwards, here we can then say if type of op.symbol is not undefined, then we say op.symbol okay, we need to do that in the loop itself, don't we? Like that. If then op.symbol becomes underscore op.symbol, so that we keep the same value and we keep overwriting it. Perfect. Perfect. And that needs an underscore. Awesome. Git status, git commit -a -m. Correct support for overwriting condition variables in loops. Yeah. Git status. And let's do this at the beginning, just in case you want to be super tricky. Yeah, git commit -a -amend. Okay, git push origin master. Cool. And then we yarn test again with updating everything. Wonderful. And now I can go find loops. Yes. No, that's still not gonna be good because now we are overwriting the variable. Yeah, no. I'm just not gonna support the case where it's not implemented first. And I think that's going to be best. We're just gonna remove this part. And sucks to be you if you are relying on it getting defined immediately. Let's do that again. Perfect. Okay. So we now have this thingy. Export PNG, blah, and then where was I? Const code. This. And we delete this guy, this, and this. Export PNG. Damn. And now we have great lolcode macro success. Yes. So we have this, and we have this. Awesome. So I'm gonna stop live coding now. Thanks everyone for watching. I will see you again maybe Thursday. I guess we'll see. Thanks for watching. Hope you had fun. I definitely had a lot of fun.